Hello friends, you are welcome in Collegiate-Physics classes. This is the second lecture of this Collegiate-Physics classes for physics students of the new syllabus 4-year degree course. In the first class, I have explained about frame of reference, the two frames of reference, inertial and non-inertial frames of reference. Today, I will explain the lab frame of reference. Lab frame of reference. Lab frame of reference. It is also called laboratory frame of reference or L frame of reference. It is defined as the frame of reference which is centered on the laboratory where the observations are made, where the experiments are done. This is the definition of L frame of reference. It is a local frame of reference. Local in this sense that it is fixed in the laboratory, and by saying local frame of reference, we want to explain that in this frame of reference, the value of gravitational force is assumed to be everywhere constant, everywhere uniform, because it is local frame of reference. Its dimension is very small. It is limited up to the laboratory. In local frame of reference, we assume three coordinates x, y, z or r, theta, phi. X, y, z is in Cartesian system of coordinates and r, theta, phi is in a spherical polar coordinate. The origin of Cartesian coordinates or spherical polar coordinates is fixed in the laboratory room. This is why it is called lab frame of reference. So, the frame of reference, lab frame of reference, I have explained it. Now the second is center of mass frame of reference. These two frames of reference, L frame of reference and center of mass frame of reference, both are needed in explaining the problem of scattering of particles. So let us see the center of mass frame of reference. As I have told that in lab frame of reference, to locate the position of a point, we take three coordinate system, x, y, z, which is called Cartesian coordinate system, and r, theta, phi, which is called spherical polar coordinates, and the origin of both these systems is fixed with the laboratory. Then it is called L frame of reference. Now, if the origin of Cartesian system of coordinates or spherical polar coordinates are fixed at the center of mass of the system, then it is called center of mass frame of reference, or it is called C frame of reference. In C frame of reference, the position vector of the origin is R, and this R is taken at 0. That is, origin is taken at the center of mass of the frame of reference. So R is equal to 0. So dr by dt is equal to 0, that is velocity of center of mass frame of reference is 0. If there is no external force acting on the system, then the center of mass frame of reference has constant velocity. So, in absence of external force, the velocity of the center of mass will be either 0 or constant. Therefore, we can say that the center of mass frame of reference is also an inertial frame of reference. So, both lab frame of reference and center of mass frame of reference both are inertial frame of reference. They are the type of inertial frame of reference. They are useful in explaining the scattering of particles. Now, the notes of this lecture can be taken from the description of this video, and you can get it there. If you have some problem, you can give me. We will try to remove your problem. And at this point, we are stopping this lecture. Thank you for attending the lecture.